Look at your arm right now. Beneath your skin, flowing through your veins, is blood that carries the memory of a catastrophe. Your immune system, the way your body fights infection, was shaped by a plague that killed half of Europe nearly 700 years ago. The survivor's genes are your genes. Their survival is why you exist. Here is something that should make you pause. Between 1347 and 1351, the Black Death swept across Europe and killed somewhere between 75 and 200 million people. In 4 years, a third to half of the entire European population died. Nothing before or since has killed so many so quickly, and the plague didn't just kill people. It changed the people who survived. Recent genetic research has shown that the Black Death was so severe, so selective in who lived and who died, that it altered the genetic makeup of European populations permanently. The plague is still with us, written in our DNA. If you are settling in for sleep tonight, this is the kind of deep history that connects directly to your own body. The defenses you carry against disease were forged in the crucible of medieval catastrophe. Subscribe and stick around. To understand how profound the Black Death was, you need to understand what Europe looked like before the plague arrived. The early 14th century was a time of growth. Populations had expanded, cities had swelled, trade networks connected distant regions, life was getting better. Then came warning signs. The early 1300s brought climate deterioration. The medieval warm period was ending, and cooler, wetter weather made harvests unreliable. The Great Famine of 1315 to 1317 killed millions across northern Europe. But people recovered, they always had before. In October 1340, 12 Genoese trading ships docked at the Sicilian port of Messina. They had come from the Black Sea from trading posts in Crimea, and they brought something with them that would change the world forever. Most of the sailors were already dead. Those still alive were covered in black boils that oozed blood and pus. They had fevers, they were vomiting, and they stank of decay even while living. The harbour authorities ordered the ships to leave, but it was already too late. The plague had already escaped into the city. Rats from the ships had scurried onto the docks, carrying fleas, and the fleas carried bacteria. Yersinia pestis, a microscopic killer that would devastate a continent. Within days, Messina's citizens began dying. The disease spread with terrifying speed. From Sicily, it moved to the Italian mainland. By January 1348, it had reached Venice, Genoa, and Pisa. By spring, it was in France. By summer, England. By the following year, it had spread across Scandinavia into Russia and throughout the Mediterranean. Let me tell you more about how the plague actually traveled, because understanding the mechanics of its spread helps us appreciate both the horror of the medieval experience and the strange luck that determined who lived and who died. The plague traveled fastest along trade routes. Ships carried it from port to port. A merchant vessel could bring infection from one city to another in days. Inland, the disease followed roads and rivers, moving with the endless traffic of medieval commerce. Some places were hit harder than others. Crowded cities with poor sanitation suffered catastrophically. Rural areas sometimes escaped relatively lightly. Fewer people meant fewer opportunities for transmission, but no place was truly safe. The season mattered too. Plague spread most efficiently in warm weather, when fleas were most active. Summer was the killing season. Cold winters sometimes slowed transmission, giving survivors a brief respite before spring brought renewed death. Monasteries and convents were devastated. These communities lived in close quarters, shared meals, and were obligated by their vows to tend the sick. The very virtues of religious life, community, charity, care for the suffering, became vectors of death. Universities emptied. Oxford reportedly lost 2/3 of its scholars. Entire faculties died. The accumulated knowledge of centuries was at risk of being lost when those who carried it perished. Some knowledge was lost. How much we'll never know. The clergy were hit especially hard. Parish priests were required to visit the dying, hear confessions, administer last rites. Each visit was an exposure. By some estimates, half the clergy in England died during the Black Death. This had profound consequences for the Church. With so many priests dead, standards for replacements dropped. Poorly trained clergy entered service, diminishing the quality of religious instruction. Some historians see seeds of the Reformation in the Church's plague, weakened state. Doctors and healers died in terrible numbers. Their profession required contact with the sick. Medieval medicine offered no protection against plague. Indeed, some treatments may have made matters worse. Those who tried to help were often among the first to die. Some doctors fled. The famous French physician Guy de Chauliac admitted that he wanted to flee but stayed out of a sense of duty. He contracted plague but survived, one of the few physicians to do so. His written account became an important historical document. No one understood what was happening. The germ theory of disease wouldn't be developed for another 500 years. Medieval people blamed bad air, planetary alignments, earthquakes releasing toxic fumes, divine punishment for human sins, and tragically minority groups like Jews, who were massacred in some regions. The symptoms were horrifying. First came fever, chills, and exhaustion, easy to mistake for ordinary illness. Then came the buboes, swellings in the lymph nodes of the groin, armpits, and neck. These could swell to the size of eggs or apples, turning black as tissue died. The bubonic form of the plague killed about 60% of those infected, usually within a week. But the pneumonic form, when the bacteria infected the lungs, was even worse. It spread through coughs and breath, and it killed nearly everyone it touched, often within days. Contemporary accounts describe the horror in vivid terms. The Italian writer Giovanni Boccaccio, who lived through the plague in Florence, wrote that victims ate lunch with their friends and dinner with their ancestors in paradise. Death came that fast. The social fabric unraveled. Boccaccio described how brother abandoned brother, and the uncle his nephew, and the sister her brother, and very often the wife her husband. What is even worse and nearly incredible is that fathers and mothers refused to see and tend their children. The dead accumulated faster than the living could bury them. Mass graves were dug, huge pits where bodies were stacked in layers, sprinkled with dirt, then covered with more bodies. In some cities, houses full of dead were simply walled up. The streets smelled of death. Some cities lost half their populations. others lost 2/3. A few were virtually wiped out. The chronicler Agnello di Tura of Siena wrote, "There was no one who wept for any death, for all awaited death, and so many died that all believed it was the end of the world." Let me tell you about the science of the plague. What actually caused this catastrophe and how it spread so efficiently. Because understanding the mechanism helps us appreciate why it was so deadly and why it affected human genetics so profoundly. Yersinia pestis is a bacterium that normally lives in rodent populations, particularly among wild rodents in Central Asia. Fleas feed on infected rodents, pick up the bacteria, and can then transmit it to other animals, including humans, when they bite. The bacterium has evolved a particularly nasty trick. Inside the flea's gut, it forms a sticky mass that blocks the flea's digestive system. The flea becomes ravenously hungry because it can't digest its meals. It bites more frequently and more aggressively, spreading the bacteria with each bite. When the bacteria enter a human body, they target the immune system directly. They inject proteins into immune cells that disable the cell's ability to fight back. The bacteria multiply rapidly while the body's defenses are paralyzed. By the time the immune system recovers enough to respond, it is often too late. The buboes that gave bubonic plague its name are actually the immune system's desperate attempt to contain the infection. Lymph nodes swell as they fill with bacteria, dead immune cells, and fluid. The blackening is tissue death, gangrene setting in as blood flow is disrupted. In pneumonic plague, the bacteria reach the lungs and multiply there. Every cough sprays infectious droplets into the air. Anyone who breathes them in becomes infected. This form spreads directly from person to person without needing fleas as intermediaries. The medieval world was perfectly designed for plague transmission. Cities were crowded, with people living in close quarters. Sanitation was poor. Waste thrown into streets attracted rats. Fleas were everywhere, in bedding, in clothing, in the rushes that covered floors. Trade networks that had brought prosperity now brought death. Ships carried infected rats to new ports. Caravans transported plague along the Silk Road. The same connectivity that had enriched medieval Europe now ensured the disease could spread everywhere. Let me tell you about what recent scientific research has revealed about how the plague changed human genetics. This is where the story becomes personal, where medieval catastrophe connects to your own body. In 2020, 2 researchers published a groundbreaking study in the journal Nature. They had extracted DNA from the bones of people who lived before, during, and after the Black Death, and compared their genetic profiles. What they found was remarkable. The plague had imposed severe selection pressure on the human population. People with certain genetic variants were more likely to survive. People without them were more likely to die. In just a few years, the frequency of protective variants increased dramatically. The most significant change was in a gene called ERAP2. This gene helps the immune system recognize and respond to pathogens. One variant of this gene, called 2,549,794 rupees, was significantly more common in people who survived the plague than in those who died before it. Let me explain more about what the ERAP2 gene actually does. because it is a fascinating window into how our immune system works and how evolution can reshape it in response to disease. ERAP2 helps process proteins from invading pathogens into small fragments that can be displayed on cell surfaces. These fragments are like wanted posters, showing the immune system what the invader looks like. The better the display, the faster and stronger the immune response. The protective variant of ERAP2 produces a more effective version of this protein. It processes pathogen fragments more efficiently, creating better displays that trigger stronger immune responses against plague bacteria. This difference was literally life or death, but the researchers found something even more remarkable. When they tested immune cells from people with the protective variant against actual Yersinia pestis bacteria in the lab, those cells were measurably better at killing the bacteria. The protection wasn't theoretical. It was real and measurable. The study also examined the genomes of people who lived before the plague, using DNA from skeletons dated to the centuries before 1347. The protective variant existed then, but it was less common. The plague increased its frequency dramatically. This is exactly what evolutionary theory predicts. A variant that improves survival will become more common in the population over time. The plague compressed what might normally take thousands of years into just a few generations. People who carried 2 copies of the protective ERAP2 variant were about 40% more likely to survive the plague than those who didn't carry it. In a pandemic that killed half the population, 40% increased survival was the difference between genetic lineages continuing or ending. The researchers found that the protective variant increased in frequency by about 10% during the plague years, an enormous change in evolutionary terms. Normally, such changes take thousands of years. The Black Death accomplished it in 4. This is natural selection happening in real time, on a scale visible in human genetics. The plague was so deadly, so selective, that it reshaped the gene pool of an entire continent within a single generation. Your ancestors who survived, they likely carried these protective variants. But here is a fascinating twist. The same genetic variants that protected against plague appear to increase susceptibility to autoimmune diseases like Crohn's disease and rheumatoid arthritis. Evolution made a trade-off, better plague resistance in exchange for higher autoimmune risk. This might explain why autoimmune diseases are more common in people of European descent than in other populations. The genes that saved our ancestors from plague now make us more likely to attack our own tissues. The plague's legacy cuts both ways. The ERAP2 gene isn't the only one affected. Researchers found changes in multiple genes involved in immune function. The plague reshaped our entire immune system, selecting for variants that could fight this particular pathogen more effectively. Let me tell you about the social and cultural changes the plague brought. Because the Black Death didn't just change genes, it changed everything about European society. The world that emerged from the plague was fundamentally different from the world that entered it. Before the plague, Europe was a society of abundance, of people at least. Labor was cheap because workers were plentiful. Serfs were bound to the land with few rights and little bargaining power. The feudal system kept most people poor while a small elite prospered. After the plague, labor was suddenly scarce. Half the workers were dead. The survivors could demand higher wages, better conditions, freedom from serfdom. Peasants who had been trapped for generations could now bargain, or simply leave for better opportunities elsewhere. Landlords were horrified. They tried to freeze wages and restrict movement through laws like England's Statute of Labourers. But the laws were unenforceable. When half your workers are dead, you can't afford to alienate the survivors. The balance of power had shifted permanently. Some historians credit the plague with beginning the end of feudalism in Western Europe, the rigid social hierarchy that had lasted for centuries cracked when there weren't enough peasants to maintain it. From the ruins of the old order, something new began to emerge. The plague also changed attitudes toward death and religion. The medieval church had taught that plague was divine punishment, that proper piety would bring protection, but the pious died alongside the sinful. Priests died as readily as thieves. Faith was shaken. Some responded with intensified religiosity. Flagellant movements spread across Europe. Groups of people who publicly whipped themselves, believing physical penance could appease God's wrath. Others responded with hedonism. If death could come any moment, why not enjoy life while you could? Art and literature changed dramatically. Before the plague, medieval art emphasized heavenly rewards and spiritual transcendence. After the plague, a new genre emerged, the danse macabre, or dance of death, showing skeletons leading people of all ranks to their graves. Let me tell you more about how the plague changed European culture. The psychological impact of watching half your world die shaped art, literature, and thought for generations afterward. Before the plague, medieval art was largely religious and optimistic. Scenes showed saints in glory, Christ triumphant, the rewards awaiting the faithful in heaven. Death was present, but as a doorway to paradise, not as a terrifying end. After the plague, art became obsessed with mortality. The transy tomb appeared, monuments showing the deceased in two states, in life above as a rotting corpse below. The message was memento mori, remember that you will die. Skulls appeared everywhere in art, in paintings, in sculpture, in decorative objects. A skull on a scholar's desk reminded him that his learning would end in death. A skull on a merchant's table reminded him that his wealth was worthless in the grave. Literature changed too. The Decameron, written by Boccaccio during the plague, frames its stories around young people fleeing Florence for the countryside. They tell tales to pass the time while death rages in the city. Entertainment as escape from horror. Poetry became darker. The traditional courtly love poems gave way to verses about death, decay, and the vanity of earthly pursuits. The ubi sunt tradition, poems asking, where are they now? Flourished as people contemplated all who had died. Religious practice changed in complex ways. Some became more devoutly pious, seeking divine protection through intensified worship. Others became skeptical. If God would permit such suffering, what kind of God was he? Both responses would shape European religion for centuries. The flagellants deserve special mention. These were people who processed through towns, publicly whipping themselves, believing they could atone for humanity's sins, and end the plague. The movement spread rapidly across Europe before the Church suppressed it as potentially heretical. The flagellants sometimes led pogroms against Jews, blaming them for poisoning wells and causing the plague. Thousands of Jews were murdered across Europe during the Black Death, adding human-caused atrocity to natural disaster. Scapegoating flourished when people desperately sought explanations. The message was clear: death came for everyone, regardless of rank or wealth. The king and the peasant, the bishop and the beggar, all would dance with death eventually. This was a more egalitarian vision, born from the experience of seeing everyone die together. Medicine changed too. Though slowly, the failure of traditional remedies, bleeding, purging, prayers, led some physicians to question received wisdom. The seeds of empirical medicine, of testing treatments against outcomes, were planted in plague's aftermath. Universities lost many of their scholars, but those that survived opened their doors wider. The need for educated clergy, administrators, and physicians created opportunities for people who would never have had access to education before. Social mobility increased. Let me tell you about how the plague kept returning. The Black Death of 1347 to 1351 was the worst outbreak, but it wasn't the last. Plague became endemic in Europe, returning in waves for centuries. Let me tell you more about these recurring outbreaks, because they're crucial for understanding both the genetic impact and the social changes the plague brought. The plague returned to England in 1361, killing perhaps 20% of the population that had recovered since the Black Death. It came again in 1369, 1374, 1379. Each outbreak killed fewer than the Black Death, but together they kept the population suppressed for generations. Children were particularly vulnerable to these later outbreaks. Having not been exposed to the first wave, they lacked whatever immunity the survivors might have developed. The 1361 outbreak was sometimes called the mortality of children. For this reason, the population of Europe didn't return to pre-plague levels for over 150 years. Some regions took even longer. This prolonged population decline had profound effects on everything from agriculture to architecture to social structure. With each outbreak, the genetic selection continued. Those who survived the first plague might succumb to the second. Those who survived both might die in the third. Generation after generation, the gene pool was refined for plague resistance. By the time plague finally retreated from Europe in the 18th century, the population had been through over 300 years of selection pressure. The genetic changes weren't just from the Black Death. They accumulated across 15 generations of exposure. This extended exposure explains why the genetic changes are so pronounced. A single epidemic, even a severe one, might not shift gene frequencies as dramatically, but repeated epidemics over centuries created a sustained selection pressure that fundamentally reshaped European genomes. The plague's retreat wasn't due to the disease becoming less deadly. Modern Yersinia pestis is just as virulent as the medieval strain. The retreat had multiple causes: better sanitation reducing rat populations, quarantine measures becoming more effective, and perhaps some level of acquired immunity in the population. Major outbreaks occurred roughly every decade or generation throughout the late medieval and early modern period. London's Great Plague of 1660, 5 killed perhaps 100,000 people. Marseille lost half its population to plague as late as 1720. Each outbreak imposed additional selection pressure on the population. The genetic changes that began during the Black Death continued to be reinforced with each new epidemic. Those with protective variants kept surviving. Those without kept dying. This is why the genetic impact of the plague is so pronounced. It wasn't a single event, but a centuries-long process of selection. European genomes were shaped by repeated exposure to Yersinia pestis over roughly 400 years. The plague finally retreated from Europe in the 18th century. Why? No one is entirely sure. Better sanitation probably helped. Changed rat populations might have played a role. Quarantine measures became more effective. But the bacterium didn't disappear. It retreated to its reservoir populations. Yersinia pestis still exists today. It lives in wild rodent populations in Central Asia, Africa, and the Americas. Small outbreaks still occur. The United States typically sees 7 plague cases per year, mostly in the Southwest. With antibiotics, the disease is now treatable if caught early. Let me tell you about what scientists have learned by studying the actual bacteria from plague victims. Because researchers have now sequenced the genome of Black Death bacteria extracted from medieval skeletons. And what they found tells us something important. In 2011, scientists extracted Yersinia pestis DNA from victims buried in London's East Smithfield Plague Cemetery, a mass grave used specifically for Black Death victims in 1348 and 1349. They sequenced the complete genome of the medieval bacteria. Remarkably, the medieval bacteria were almost identical to modern strains. The Black Death wasn't caused by some super virulent variant that later evolved to be milder. It was essentially the same bacterium that still causes plague today. This means the massive death toll wasn't because the bacteria were unusually deadly. It was because the population had no immunity. Europeans had never encountered Yersinia pestis before. Their immune systems were completely naive to this pathogen. The genetic changes that occurred during and after the plague were essentially Europeans developing resistance. The variants that increased survival, like the ERAP2 variant, helped the immune system recognize and fight the bacteria more effectively. This is how evolution works in response to disease. The pathogen doesn't necessarily change. The host population changes. Those who can resist survive and reproduce, while those who can't are eliminated. Over time, the population becomes more resistant. We see this pattern throughout human history. Populations that have long exposure to a pathogen develop resistance. When they encounter populations without that exposure, the results can be catastrophic, as happened when Europeans brought Old World diseases to the Americas. Let me tell you about the human experience of living through the Black Death. Because behind the statistics and the genetics are individual people facing unimaginable horror. Imagine waking one morning with a headache and slight fever. You think nothing of it. Such symptoms are common, but by evening, you are burning with fever and too weak to stand. Your family puts you to bed, worried but not yet terrified. The next day, you feel a painful swelling in your groin, a hard lump, tender to the touch. You know what this might mean. Everyone has heard the stories. But maybe it is something else. Maybe you'll be one of the lucky ones. By the third day, the bubo has swollen to the size of an egg. It is turned purple, then black. The pain is excruciating. You drift in and out of consciousness, tormented by fever and thirst. Your family tends to you but keeps their distance when they can. Some victims recovered at this point. The bubo would burst, an agonizing relief, and the infection would drain. If you survived the next few days, you might live. You'd be scarred, weakened, but alive. About 40% of bubonic plague victims recovered, but for most, there was no recovery. The bacteria spread through the bloodstream, causing septicemia. Dark patches appeared on the skin as blood vessels burst. Internal bleeding began. Death came within a week of the first symptoms, often sooner. And then your family had to decide what to do with your body. In the early days of the plague, proper burials were still possible. Priests came to give last rites. Coffins were built. Graves were dug in churchyards. As the death toll mounted, that became impossible. There weren't enough coffins, enough priests, enough grave diggers. Bodies were collected in carts and dumped in mass graves. Some were burned. Some were simply left where they died. The chronicler Henry Knighton described the situation in England. There was such a shortage of servants, craftsmen, and workmen, and of agricultural workers and labourers, that a great many lords and people, although rich in goods and possessions, were yet without service. Entire villages were wiped out. Archaeological excavations have found settlements that were simply abandoned, every own dead or fled. The landscape of Europe was dotted with ghost villages, farms reverting to wilderness, churches with no congregations. Let me tell you about the long-term consequences of the Black Death, because the changes it brought, social, economic, cultural, genetic, shaped the world we live in today. Let me tell you more about specific economic and social changes, because the details illustrate how profoundly the plague transformed European society. The Peasants' Revolt of 1381 in England was directly connected to plague aftermath. Workers who had gained bargaining power resented attempts to reimpose old restrictions. When a poll tax was levied, decades of accumulated grievance exploded into open rebellion. The revolt was eventually suppressed, but it demonstrated that the old order couldn't be fully restored. Peasants who had tasted freedom wouldn't easily return to serfdom. The process of feudal decline, accelerated by plague, continued despite the revolt's failure. Wages for skilled craftsmen doubled or even tripled after the plague. A mason who had earned 3 pence per Dalton Y before 1340, 7 might earn 6 or 8 pence afterward. This wasn't inflation, it was genuine increase in purchasing power. The diet of ordinary people improved. With fewer mouths to feed and the same amount of land, survivors ate better. Meat consumption increased. People were generally healthier and better nourished, one of the few positive consequences of the catastrophe. Women gained some economic independence. The labor shortage meant women could take on roles previously reserved for men. Widows who inherited property became more common. Though limited by the standards of the time, women's economic position improved. The wool trade shifted. England had exported raw wool to Flanders for processing into cloth. After the plague, with labour scarce and expensive everywhere, it became profitable to do the processing in England. The English textile industry expanded with long-term economic consequences. The labour shortage after the plague fundamentally changed the European economy. With fewer workers, those who survived could demand higher wages. Land that had been cultivated for centuries was abandoned as there weren't enough hands to work it. This led to technological innovation. Labour-saving devices became valuable when labour was expensive. Watermills and windmills spread. Better ploughs were developed. The foundations of the agricultural revolution were laid in response to plague-induced labour scarcity. The printing press, developed in the 1450s, might partly be a response to plague conditions. Fewer scribes meant alternatives to hand. Copying texts became valuable. Gutenberg's invention transformed knowledge transmission, and the scarcity of skilled labour helped make it economically viable. Some historians argue the Black Death accelerated the Renaissance. The old certainties had been shattered. New wealth flowed to survivors who inherited from the dead. The Church's authority was diminished. Space opened for new ideas, new art, new ways of seeing the world. The plague also accelerated the development of public health institutions. Quarantine, from the Italian 40 giorni, meaning 40 days, was invented in response to plague. Health boards were established to track disease and enforce isolation. The foundations of modern public health were laid. These institutions would prove essential in future epidemics. The lessons learned fighting plague were applied to other diseases. The very concept that governments should protect public health emerged from medieval plague responses. Let me tell you more about the scientific investigations that revealed the genetic legacy of the plague. Because the detective work involved is itself a remarkable story. Researchers faced enormous challenges. They needed DNA from people who lived before the plague, during the plague, and after the plague. They needed to compare these samples to see what had changed. This required finding and excavating medieval cemeteries across Europe. The East Smithfield Cemetery in London was particularly valuable. This burial ground was used specifically for Black Death victims in 1348 and 1349. Bodies there definitely died from plague, and the dating was precise. It was a genetic time capsule. Extracting DNA from 700-year-old bones is incredibly difficult. DNA degrades over time, and contamination from modern sources is a constant problem. Researchers had to develop new techniques to isolate ancient genetic material and distinguish it from modern contamination. They focused on teeth, which are the best preserved part of the skeleton. The inner pulp of teeth contains DNA that is protected from the environment. By drilling into teeth from plague victims, researchers could extract genetic material that had been sealed away for centuries. The comparison revealed dramatic changes. Certain immune-related genes showed clear evidence of selection. Variants that were uncommon before 1348 became much more common afterward. The plague had reshaped the genetic landscape of Europe in just a few generations. The ERAP2 gene showed the strongest signal. This gene helps cells present pieces of invading bacteria to the immune system. The protective variant produces a more effective version of this protein, enabling faster and stronger immune responses against bacterial infection. But the researchers found something unexpected. The same protective variants that helped against plague are associated with increased risk of autoimmune diseases. Evolution had made a trade-off: better plague resistance in exchange for increased risk of the immune system attacking the body's own tissues. This helps explain a modern medical mystery. Why are autoimmune diseases more common in people of European descent? The answer may lie in the Black Death. The genetic adaptations that saved our ancestors from plague now predispose us to rheumatoid arthritis, Crohn's disease, and other autoimmune conditions. The research also revealed that Yersinia pestis from the Black Death was essentially identical to modern plague bacteria. The medieval strain wasn't a super-virulent version that later evolved to be milder. It was the same organism that still causes plague today. This means the massive death toll wasn't because the bacteria were unusually deadly. It was because Europeans had never encountered them before. Their immune systems were completely naive to this pathogen. They had no inherited resistance, no prior exposure, no defenses. Let me bring this back to the genetic legacy we all carry. Because the Black Death isn't just history, it is biology. It is written in your DNA, shaping how your body fights infection today. If you are of European descent, you likely carry genetic variants that became common because they helped your ancestors survive the plague. Your immune system is calibrated differently than it would be if the plague had never happened. Let me share some thoughts about what this genetic legacy means for how we think about ourselves. Because carrying plague survivor DNA changes how we understand our own biology. Your immune system isn't just yours. It is a collective inheritance shaped by countless ancestors who faced countless diseases. The white blood cells patrolling your body right now carry programming that was tested against the Black Death. They're using strategies that proved effective 700 years ago. This is evolution made personal. We often think of evolution as something that happened long ago, to distant ancestors in environments nothing like our own. But the Black Death shows evolution happening in historical time, to people like us. In circumstances we can imagine. It also shows how randomly survival can be distributed. The people who survived the plague weren't morally superior or more deserving. They simply happened to have genetic variants that helped against this particular disease. Luck, genetic luck, determined who lived and who died. This has implications for how we think about disease and blame. When plague struck, people blamed sinners, Jews, foreigners. They assumed the afflicted must have done something to deserve their fate. But biology doesn't work that way. Disease strikes based on exposure and susceptibility, not on moral worth. The plague survivors passed this lesson too. Modern public health emerged from the understanding that disease is a natural phenomenon, not a moral judgment. Quarantine, sanitation, vaccination. These work because disease follows biological rules, not divine whims. This has implications for modern medicine. Understanding how plague shaped our immune systems helps researchers understand why certain diseases affect certain populations differently. The evolutionary history of disease is written in our genes. The autoimmune connection is particularly important. Those protective variants that helped against plague appear to increase inflammation generally. This was good for fighting bacteria but may contribute to chronic inflammatory diseases that plague modern populations. We are, quite literally, shaped by our ancestors' catastrophes. The diseases they faced, the selection pressures they survived, the genetic variants that saved them, all of this is encoded in our genomes. We carry history in every cell. The geneticist and science writer Carl Zimmer has written that we are mosaics of our ancestors. Every cell in your body contains DNA contributed by countless individuals stretching back through time. The plague survivors are part of that mosaic. Their legacy is woven into your very being. When you fight off an infection, you are using tools that were tested in the worst pandemic in history. When your immune system recognizes an invader, it is using recognition systems refined by centuries of plague exposure. You are the beneficiary of their suffering. Think about this as you drift towards sleep tonight. Your body is a historical document. Every genetic variant tells a story of survival. The immune system protecting you right now was forged in medieval pestilence, refined over centuries, and handed down to you. The people who lived through the Black Death couldn't have known they were shaping the future. They were just trying to survive, just trying to protect their families, just hoping the nightmare would end. They didn't know their survival would echo through centuries, but their survival is why you exist. The genetic variants that saved them were passed to their children and their children's children, and eventually to you. You are the living legacy of people who faced unimaginable horror and didn't die. That is a powerful thing to carry with you. Not just survival, but the tools of survival. The genetic adaptations that helped your ancestors fight off a disease that killed half the continent. You are descended from survivors. That is written in your blood. The Black Death was the worst catastrophe in European history. It killed more people more quickly than any other disaster. It shattered the medieval world and built something new from the ruins. It changed society, culture, religion, economics, and medicine. And it changed human biology itself. Not through supernatural forces, but through natural selection, the differential survival of people with different genetic variants. Evolution in action, compressed into a few terrible years, still visible in our DNA today. We don't know when the next pandemic will come. History suggests there will be one. Diseases have devastated human populations regularly throughout our existence. But we face future threats with the genetic legacy of past survivals. And with something our ancestors didn't have, scientific understanding. We understand now what the plague was. We understand how it spread, how it killed, how it selected for survival. We can develop vaccines, antibiotics, treatments our ancestors couldn't have imagined. The knowledge they died without, we now possess. But we also carry their adaptations. The immune responses that evolved in the crucible of medieval catastrophe are still operating in our bodies. When you get sick and recover, you are using tools that were tested against the Black Death. You are continuing a process that began 700 years ago. If you are drifting off now, let these thoughts settle gently. Your body is older than you are, not in years, but in generations. The defenses you carry were built across centuries. You are the latest version of a survival system that has been refined since the medieval world. The people who died in the Black Death are gone. We don't know their names, their stories, their hopes, but the people who survived, their genes live on in you. In everyone of European descent, their survival was the beginning of your existence. Thanks for spending this time with me tonight, thinking about plague and survival, and the strange ways history writes itself in our bodies. There are more mysteries to explore on this channel. Subscribe if you haven't, and I'll see you next time. Good night. Sleep well, and know that while you sleep, your immune system is standing guard, using tools forged in medieval catastrophe, refined across 700 years, and entrusted to you by ancestors who survived so that you could exist.